Good morning, everyone. I'm Vanessa Little. I sit on the OSM Technical Steering Committee, and I currently work for VMware as the Director of NFV Ecosystem Architecture. So today I'm going to chat a little bit about the OSM architecture, and I'm going to touch on a little bit of the methodologies behind the data models. And if we have time, we'll take a few questions. So today we're going to discuss the architectural principles that drive OSM all the way through release 0 to its current release, how we scope and map to the ETSI NFV architectures and where we align to those standards and where we've made some concessions, and how that feedback loop works back into ETSI NFV. And then we're going to discuss the actual core architecture of the current release. And we're going to talk about the upcoming architectural goals and themes. So looking a little bit ahead to release 4 that's coming out in a bit. What are the exciting things that are happening there? So the 4 core principles that we've had as our sort of our core pillars in all of our architectural decisions have been these 4, and that is we want a layered topology. We want to be able to achieve abstraction so that users of the system don't need to have a detailed, intimate knowledge of every layer and every component. We want it to be modular enough so that we can bolt other components in and remove components out as technology evolves so that we don't lock ourselves into any particular types of technologies or code bases. And finally, we want it to be simple. We want people to actually use this management and join the community. So we want to make sure that we're making architectural decisions that drive that level of simplicity to make it not only easy to use, but also easy to join the community and contribute code. So how we map to the ETSI NFV Mano architecture, you'll see here, and you'll see this slide will recur in a number of decks throughout the presentations today. We have the runtime scope and the design time scope, and those are the 2 core features that we're seeing in the open source Mano architecture. But you'll see here, the interfaces that we've decided to implement are outlined here. And this is how they align. So we have automated end-to-end service orchestration, a plugin model for integrating multiple SDN controllers as well as VIMs, a plugin model for monitoring tools so that you can bolt in different technologies, both commercial and open source, depending on what your preferences are. We have integrated generic VNFM support, as well as support for physical network function integration that Francisco Javier touched on a little bit earlier. And we're looking to support greenfield and brownfield deployments. So the whole purpose of the runtime scope is that it's extremely flexible. You'll see in here that using a plugin-based model allows us to snap in any kind of technologies as they become relevant and decommission technologies as they're no longer relevant. And then when we look at the design time scope, we have a big focus on network service definition and modeling, and I'll touch on that a bit later. And we have model-driven environment with data models aligned with ETSI NFV, but not exactly identical to ETSI NFV. And so as ETSI NFV innovates and comes up with newer versions of the model, we fall in lockstep where it's appropriate to OSM. And finally, we have VNF package generation tools and a very spiffy GUI. And this is, so when you see the overlay of the OSM components on top of the ETSI NFV architecture, it becomes a little more obvious where all these different components live. So looking a little deeper into the OSM architecture, we have what we call our DevOps pillar, and that includes our one-click installer, our CI/CD pipeline, that includes Jenkins automations, that we automate our test-driven development. Then we have our user interface, which includes our VNF package generation, the catalog composer, account management, and the OSM command line client as well. Then we have our service orchestration, or the SO component, and here's where all of our API service management endpoint exists, or the API service management endpoint for the service orchestrator. It's got the configuration data store, catalog management, and all of the things that compose service orchestration. Below that, we have the resource orchestrator. So you see we've separated service orchestration from resource orchestration. The resource orchestration is what orchestrates the resources. This is where we have our plugins for the Vim connectors, the plugins for the SDN connectors, the resource orchestration engine, so the workflow engine, and it's also got some API service and utilities in there as well. Then we have our network service to VNF communication and the VNF configuration and abstraction layer here. This composes the N2VC and the VCA engine. So those of you who are more familiar with the code base itself, the VCA engine is all driven by Canonical's Juju. And then finally, we have our monitoring components. We have our core monitoring solution here, where we're able to aggregate and bring in through a series of plugins different monitoring telemetry from different components of the infrastructure. So where the Vim provides it, we have plugins for VMware and the vRealize operations, so more commercial solutions. We have plugins for AWS CloudWatch. We also have some plugins for Gnocchi and ADOH. And all of these different components are completely interchangeable. And so the monitoring plugin tool abstracts those telemetries and brings them into OSM so that we can move closer and closer towards closed loop service orchestration and self-healing infrastructures. And then finally, we have the OSM data model, which transcends the entire infrastructure. So what we're looking at going forward is consolidating the OSM northbound interface so that it aligns with the Sol 5 and Sol 4 improvements that are coming up in the ETSI NFV communities. And the reason why we decided to do this is it no longer made sense to have disparate APIs in our various components. It makes more sense to have one northbound API so that OSS and BSS integration becomes much simpler, much more elegant. Achieving this is not trivial, I would say, but it's also not very difficult. And the time is right in the current code base to make the move toward this consolidated API. And it uses a very simple architecture where messages use a common bus, messages use a common database, and the information model uses a common database so that we are able to achieve this northbound API that under the covers touches all the various components like the SO and the RO and the VCA, but northbound to the user, it's abstracted as one unified API interface. So coming up in release 4, the consistent themes that have been spanning all of the releases have always been service assurance. So how do you update a running service? How do you monitor a running service? How do you scale a service? Looking at fault management, fault tolerance, making the infrastructure itself a little more robust and fault tolerant. Then usability. So consolidating all of these disparate logging infrastructures and normalizing that data and doing something useful with it was a big part of Release 4 in the newer monitoring module, which is now no longer experimental. It's a fully featured component of Release 4. Resiliency. So how do you scale out the OSM infrastructure itself? How do you make that fault tolerant? This was a very key pillar in Release 4 in making the infrastructure more usable and production ready. And finally, the CI/CD pipeline, just having a little bit better hygiene within the OSM community to be able to drive that test-driven development and release more robust code so that there isn't a giant regression test effort at the end of each release, but rather as code is checked in, it is tested, it is qualified before it actually hits the core code base. So new themes that have come up as of Release 4 are this concept of validated VNFs. And so being able to have a catalog of pre-built data models, pre-built VNFDs and NSDs for qualified VNFs so that people can download and test them without having to sit there and write the Yang models from scratch. More robust documentation. one of the most common themes that we're seeing from the OSM community and the people that are testing, using, and playing with it and attempting to deploy it is we'd really like to see a little more in the documentation. And this is not only from people using open source manual, but people developing against it as well. And we've come to realize that if we want to attract new blood into the development community to actually contribute to this code base, we need to make sure that we've documented very thoroughly what we've done so far, what our goals are, what our development methodologies are, how the CI/CD pipeline works, et cetera, et cetera. And now that we've come much closer to developing that type of documentation, we're seeing a much more robust code base as a result. And finally, we're starting to look at container-based VNF deployments, and we've had a number of demos at our last plenary that are starting to touch on this, as well as some interesting work in unikernels. And so while we're seeing this more forward-thinking innovation in the code base, there's also a huge focus on making the code base very robust and usable and production ready. So the information models. So I just threw this slide in here so that we could just pause for a minute and articulate the difference between information models and data models. Information models are what comes out of the standards bodies, and they're more conceptual. They're meant for designers as a guideline for what should be implemented. The data models are actually the more concrete, detailed model that are used by orchestrators like OSM. And so when you look at NFV Phase 1, and it has now shifted into Phase 2 with the IFA 11 and IFA 14 specs. The early days in OSM Mano, we looked at the Phase 1 specs, and now we look more towards the Phase 2 specs. So the OSM code and the OSM data model evolves with the standards that are coming out of NFV. And so now, as the Phase 1 models are obsoleted, we're seeing that reflected in the actual usable data models that are deployed in the open source communities. So Oasis Tosca is seeing an evolution more towards NFV. The various different Yang models in the open source communities are also migrating towards these new models, as well as the NFV Sol 1, which is still a work in progress. So we have a few minutes for questions. If anyone has any questions about the steering committee, the architecture, the data models. Oh, sure.
Thank you. I have a question concerning this information model and versus data model. You mentioned Yang and Tosca. I think Yang is not Yang and Tosca is not Tosca. How will you manage that? Because I saw a picture delivered by IETF. There are a couple of different versions from the information that was presented.
Yeah, so when we mentioned Yang here, we discussed it as Yang as the markup language, not necessarily the NFV Yang model. There is no one model for NFV, whether it be in Tosca or in Yang. And if you look at even the Tosca models across the industry, there are, I believe, 6 different commonly used iterations of the Tosca model that have been extended and modified in unique ways in order to achieve some of the NFV capabilities. So yeah, to your point, there is no one model. There is no Yang model. There's OSM's implementation, which happens to be in Yang. There's ONAP's implementation, which is in Yang, as well as they have a Tosca model. There's Cloudify's Tosca model. Rift uses Yang models, and none of them are completely identical. They're all unique.
That is the reason for my question. This is a concern that I have, that finally we have so many different models up and running that we have not a model, not a standardized model. We have, again, proprietary solutions. And I think that is not what the industry is needed to be successful in terms of automation. I think that is something what we have to discuss more in detail, how we can achieve really a model and not talking about a modularization, but it's not a model.
It's true, and this has been a conversation in the community since the community's inception. Whose model is the best one? Whose model is the most correct? Who knows? I'd say they all have different levels of correctness for their specific use cases and their specific implementations. It's not really for any one body to say this is the one model. This is the one model. This is the one ring to rule them all. I think it would be really arrogant of anyone to say this model's better than that model. What we can do as members of the standards community is try to drive a unified model that encompasses all of them. Are we going to be able to please everybody? No, probably not. But eventually someone has to win.
I'm, okay, that's fine.
Yeah, I think, thank you. This morning we talked about having the right level of abstraction. What some of my network guys tell me is that if the information model at the right level, we have to figure out what level that is, but if the information model is consistent, then we can translate from one data model to another. It's not a big deal actually in software to transform from one model to another. Say even Yang and Tosca have some different uses, but let's say from a Yang to a Tosca, we can do that as long as the overall information model is aligned. The problem is if we have a misalignment, then this translation would become a stateful box in the middle. That'd be terrible. So I think the solution would be to try to come up with the right level of abstraction, maybe in a standards body, maybe ZSM or somewhere, and then have open source actually have concrete solutions that are data models. Yeah,
and that brings up an interesting point. There actually are open source communities that are looking at translating between the models. And what we're discovering is there's no one-to-one translation. It's sort of like if you put a paragraph through Google Translate and put it through 9 different languages and then back to the original language, it's nowhere near what the original sentiment actually was. And so Serge's point about a unified information model, conceptually, we're very close. I think we all agree on how to define things like EPA, memory, state, infrastructure, requirements for deployment. I think all of those are universal, and I think every data model encompasses these. So there's not a lot of contention there. I think it's just a matter of recognizing, okay, this is a complete suite of what we believe we need for NFV today, and that's always going to be a moving target. But I think if we can zero in on universally agreeing, these are the conceptually all of the different things that we believe we need, then the different implementations can follow suit. And with that, I will say, I'm sorry we have no more time, but I can catch up with you later. All right, thank you.